pull it back a little.
That's Max. That's my little guy. See him in the video playing the drums? Oh, he wasn't here. That's right. So anyway.
Yeah, I can.
Hey, well, good. So, good. You see Max, he's kind of smiling and being a goofball, and then you look down at his feet. And this was when the summer he started wearing Crocs, and they were bright yellow. And I noticed a few times, and then I had to repress the adorability of this. I didn't make a big deal about it, because I wanted to study it. So what I did was, I watched him what I thought were 10 randomly selected times throughout the course of the summer. And I noticed that he only got the Crocs on the correct feet 1 time out of 10. 1 time out of 10. Okay. So the question I had for myself was, is he guessing when he puts the shoes on? Because he had just started wearing Crocs. And I spent a lot of time, as you see, barefoot. I do wear Crocs a lot in the summer, but at this particular summer I was going barefoot a lot, working a lot in the yard barefoot. So he didn't have like a model to work off of. So a new pair of shoes. We also have a lot of ducks in our pond. So he's got ducks walking around. Maybe he wants to see people like ducks, I don't know. So the question I have is, do you think Max is guessing based on this? Based on this, do you think Max is guessing? So, and Shelby says no, I don't think so. How come?
Because if he was guessing, wouldn't it be a 50% chance
Boom.
anyway?
Here's where your program comes in. You ready? Fire your program up. Fire your program up. We can actually make this a perfectly unskewed distribution, Denny, per order. Here we go. So we can create the distribution, because what Shelby just said was, wait a minute now, time out, time out. If he's guessing, he should get it right half the time. That makes sense, yeah? So if I watch him 10 times, he should get it right
5 times.
5 out of 10. Half of 10 is 5. But here's the question. Is 1 far enough from 5 to make me think it's not 5? That seems stupid because it's a stupid mathematical question, but my question is it unusually far away from 5? So in this case, the average doesn't help us as much as the what? As far as being far away from an average, what would help us more than just the average?
Standard deviation.
Standard deviation. Now let's run it. Let's run it. Let's assume he's guessing. Assume he's guessing, yeah? Assume he's guessing. So go to programs, dist fill. If I watch him 10 times, and I'm interested in the number of times he gets the shoes on the correct feet, number of times out of 10, the shoes end up on the right feet. It could be 0. He might never get them on the correct feet. Or it could be as many as 10. And the only reason I even bring this to you guys is because he did get them on the correct feet 1 time. If it was 0 out of 10, I'd be like, what the hell? He thinks that's the right way. But he got him on the right feet once. I'm like, huh. Now again, he's my kid. He's probably got ADD too. So cuddly does my guy he's like, put his shoes on. Oh, it's the cat. And then he just puts it. So here we go. 0 to 10, boom. Binomial, if we're assuming he's guessing, it's binomial. Even if we're not assuming he's guessing, it's binomial, because he either does or doesn't. But the problem is, if we don't think he's guessing, we have to have a probability, right? We have to have a probability to put in, and I can't see inside that beautiful head of his, so I don't know what the probability is. But I can compare it to guessing. So here we go. Chance 50-50, 0.5. Here we go. Done. All right, so now this is where we can run an average, get a standard deviation if you want to. We can do it that way. Or we can look at the graph, look at the distribution. I think, because of Jamie's question, I think it's easier to do that. So in other words, you can look for outliers a couple different ways. You can look for them graphically by doing mu plus or minus 2 sigmas. Or to go to the distribution itself and look for the outliers by they're the unusual things. So here's 5. He should get it correct half the time, 25% of the time. So if he puts shoes on his feet 10 times, in 25% of cases I watch him over 10, 10, 10, he's going to get them exactly 5 and 5. That means 75% of the time he's not. He's going to do something else besides exactly half and half. But look, these are still very high, aren't they? So 64% of the time, or roughly 2/3 of the time, roughly 2/3 of the time, there's your 1 standard deviation, if you will, you're going to get it between 4 and 6. If you tack on 12% down here, this will also be 12% down here because it's perfectly symmetrical. You pick up another 24%. Now, if you go from here out to down here at 7, you've picked up roughly 90% of what's going to happen. And if you bump it out even further to 2, we're starting to get into the unusual world here, aren't we? Unusual world. 2 down to 8, you've got basically 98, almost 99% of what should happen. But where did Max fall?
Outside.
He fell below the 1% likelihood. So graphically, he fell here. He fell here, okay? Which makes me think that's his curve. That's the curve in his head. Because chances are, I didn't witness an outlier. Chances are I witnessed a usual event. You don't go out looking for outliers. Sometimes they show themselves to you, but you don't go out looking for them. So here's your type 1, type 2 error, Renee. If he indeed was guessing when he put his shoes on, he could have been guessing, and this is where he landed. My claim is that he's actually guessing at a lower rate, or he's getting the shoes on the correct feet at a lower rate because he thinks that's the way it should be. He thinks that's the way it should be. Exactly, right? So he prefers it that way, or he likes it that way, that's the way he thinks it should be. But it might be that he's only guessing, and I got this deviant data, by pure random chance. Or somehow I colored it by how I tried to be a good observer, just write it down, take a picture, and walk away. I mean, he saw me taking it here. He didn't see this one. I'm pretty sure he saw that one. But I tried to be, it's a whole Schrodinger's cat kind of thing. Don't let the observed quantity know you're observing them. Because if you do, as soon as you start observing, they start changing their behavior. So I tried, I only took 3 pictures, I just kept track when it was in the pond. Okay, yes. No, we got it right this time. No. Yes. So, but the idea is he's most likely not there, he's most likely there. Which means that that other curve is talking about where his thought process goes.
Which means he got it right to him.
9 out of 10 times.
Yeah, 90%
yes.
of the time.
See, what I'm calling wrong, he's calling right. Because in his mind, and again, it's all a hypothesis. You have no idea if you're right or wrong. The only thing you know for certain is if he's guessing, that's going to be the curve. But you don't know what's, and this is where 244 comes in, comparing curves like this all day long. Cool? Yeah, good stuff. So I don't think he's guessing. And somehow, between then and now, he now puts them on the correct feet all the time. He guess he watches mom and dad, and figures out that, if I put them like this, I don't fall on my face, and that kind of thing. Cool. Cool! Let's take 5. Let's take 5. We'll come back into this, and we're going to fuse it into our next bit.